Hello, my name is Anil Kulkarni. I will be coordinating this course on fundamental concepts of electrical supply systems. This course is motivated by some of the changes in the electrical supply system, notably the advent of renewable energy systems, distributed generation systems, information and communication technology, computer technology, and very importantly, power electronics. One of the key changes which I mentioned was, of course, the advent of renewables. And you will note here in this slide that almost 22% of the installed capacity in India is renewable energy. This photograph here shows an example of a rooftop solar system which would be actually integrated with the distribution grid. Almost all the solar PV sources and wind energy is interfaced to the system via power electronics when connected to the grid, and how they need to be controlled when connected to the grid. When you look at the kind of issues which we will face are related to protection, for example, relay coordination, voltage regulation, important aspects like what do we expect to be the ground fault over voltages. Wide area measurement systems is one of the applications of communication and information technology to the power system. Because of this also, we hope that we will have a grid which is more resistant to disturbances and we will be able to keep the lights on. We have somewhat painful memories of the July 2012 Indian blackout, where the entire northern grid was blacked out on 30th July. Specifically, let us look at what we will try to cover in this course. We will look at the key physics related to the course, that is low frequency electromagnetism, basic circuits, transmission lines, the very nature of voltages and currents. There have been some discussion on whether we can have low voltage DC grids, the concept of average and reactive power, multi-phase systems, shock safety, neutral grounding, safety grounding, short circuits, protections, and so on. We will move bottom up from understanding some of the key concepts in local electricity supply, including generation from rotating machines, basic concepts of frequency and voltage control, the nature of loads themselves as functions of voltage and frequency, and very importantly, waveform conditioning using power electronics, that is using DC to DC and DC to AC converters. And thereon we move upwards to the high voltage bulk transmission grid, and the key points which we will cover here are the new technologies in HVDC and flexible AC transmission systems, renewable energy systems and electricity storage, control of frequency and voltage when you have an interconnection as opposed to an isolated grid, effect of disturbances in the grid, in particular instabilities, and finally monitoring and control using information and communication technology. We will of course not be able to cover everything, each and every topic in this course. So what we will do is, in fact, select some key topics in which we will try to expound further, and we will try to give you examples which will bring out the concept.